Hello children, welcome to the digital class. In your 7th class, you learnt about what is data, how to organize data and how to find mean, median and mode. Okay children, now you observe the screen. Here I am showing you 2016 Olympics top 5 countries. You can observe on the screen United States with 46 gold medals, 37 silver medals, 38 bronze medals and a total of 121 medals. Like this top 5 countries you can see on the screen. Children, what I have done here, I have arranged the same data, or I can say I organized the data into a table. So here you can understand easily and you can answer questions from this table. Children, observe this. This is the data. This is also a data. Now tell me, which one is easy to understand and easy to answer the questions? Yes, definitely organized data. In this session, you are going to learn about basic measures of central tendency, arithmetic mean, median and mode, organization of grouped data, grouped frequency distribution, limits and boundaries, length of the class. Okay children, I am taking the same table here. Try to answer my questions. Which country has got the highest number of medals? So we have to look into the total. Now tell me, which country got highest number of medals? Yes, it is 121, United States. Now try to answer this question. Which country has got the highest number of gold medals? Yes, 46, again United States. Next question, which country has got the least number of bronze medals? Okay children, these are the bronze medals. In that least number is 15. Now tell me, which country got least number of bronze medals? Yes, it is Germany. Information available in the numerical form or verbal form or graphical form that helps in taking decisions or drawing conclusions is called data. Okay children, now observe the table. Here I am showing you time spent in hours by Rahul for 2 activities in a week. What are the 2 activities here? Study and play. He is Rahul. On Sunday he studied 3 hours and played for 3 hours. Monday 2 hours, 2 hours. Tuesday 2 hours, 3 hours. Wednesday 4 hours, 1 hour. Thursday 3 hours, 2 hours. Friday 4 hours, 1 hour. Saturday 3 hours and 2 hours. And total time spent to study in that week is 21 hours and to play is 14 hours. Now try to answer my question here. How many hours did Rahul study on Tuesday? Yes, you are right, 2 hours. Now answer this question. How many hours did Rahul play on Sunday? Yes, 3 hours. How many hours did Rahul study in the week? So I can say 21 hours. Okay children, now using this data, can we take a single value that can represent study per day in a week, and can we select a single value from this data, tell about the total week? Is it possible? No. Then what we need? Yes, we need to study measure of central tendency, which will be the central value which represents the total data. Basic measures of central tendency is classified into 3 types. What are they? Arithmetic mean, median and mode. Now let us understand what is arithmetic mean. The sum of all observations divided by the number of observations is called arithmetic mean. So what I am doing here, I am taking x1, x2, x3 and so on up to xn as n observations. Then how to find arithmetic mean? Yes, we have to find the sum of the observations divided by the number of observations. Children, try to understand this. Arithmetic mean is equal to sum of all observations divided by number of observations. I can denote arithmetic mean with x bar. So I can say x bar equal to sigma xi by n. Children, what is this sigma xi? Sigma stands for summation. Xi, ith observation. Suppose if I take here 1, I have to take x1. If I take 2, I have to take 2. If I take 3, I have to take 3, and I have to take up to n. So, this I can take values from 1 to n. So, what is the formula to find arithmetic mean? Yes, x bar equal to sigma xi by n. Now, let us find the mean of the data. Children, how many observations I have given here? 1, 2, 3, 4, 5, 6, 7. So, I have given 7 observations. So, how to find mean? Yes, x bar equal to sigma xi by n. So, I am taking the numbers like this. See children, this is 10.25, okay. This 9 I have taken as 9.00. 2 places I am taking here 2 zeros. So, 9 is taken as 9.00, 4.75 as it is, 8 is taken as 8.00, 2.65 as it is, 12 is taken as 12.00, 2.35 as it is. Now, what I am doing here? I am finding the sum of observations divided by number of observations. Yes, 7. So, I am trying to add these observations. If I add, what I am getting children here? Yes, 49.00. 49.00 can be taken as 49 divided by 7. Children, can we cancel these terms? Yes, 7 ones are 7, 7s are. What is 7 by 1 equal to? 7. So, mean of the data is 7. Children, observe the screen. I am reading the question. Mean of 8 observations is 25. If one observation 11 is excluded. What is meant by excluded? Taken out from the observations. Find the mean of the remaining observations. So, what is the formula to find mean? Yes, mean x bar equal to sigma xi by n. Now, mean of 8 observations, that is x bar, is given as 25. You can see children here, mean is given as 25. Now, I am finding sum of 8 observations. How to find the sum? It is very simple. If I want to find the sigma xi, what I have to do? I have to multiply this n with x bar. So, what is x bar? 25 into n, number of observations is 8. So, 25 into 8. Children, what you will get if you multiply 25 with 8? Yes, we will get 200. What is the excluded observation? Yes, it is 11. Now, sum of 7 observations. See children, here it is sum of 8 observations, but we have to find sum of 7 observations. Why? We have to take out this 11 from the sum. So, what I am doing here? 200 minus 11, which is equal to 189. Mean of 7 observations, that is x bar equal to sigma xi by n. So, I can say 189 by 7. Children, can we cancel these terms? Yes, 7 ones are 7. 2s are 14, 7 7s are 49. So, I will get 27. So, what is the mean of remaining observations? Yes, it is 27. Okay children, now let us go into the next example. Mean of 9 observations is 38. In doing so, mistakenly the observation 27 is taken instead of 72. Try to understand children here. 27 is taken instead of 72. Now, we have to find the correct mean. Mean of 9 observations, x bar equal to 38. Sum of 9 observations, what you have to do? This mean should be multiplied with the number of observations. So, 38 into 9. What I am getting here? 342. Now, an observation 27 is taken instead of 72. So, we got a error here. What is that error? We have taken 27 instead of 72, means we have taken less. So, we have to find the difference. So, 72 minus 27, which is equal to 45. Corrected sum of 9 observations. Children, here number of observations will not change. Why? Because they are as it is. Then what will be changed? Just the sum will be changed. How to change the sum? It is very simple. Sigma xi equal to this sum you have to take, and as we have taken less, see children, we have taken 27 instead of 72. So, we have taken less. So, this error should be added. What I am doing here? I am adding the error. So, plus 45. So, which is equal to 387. So, this is the corrected sum of 9 observations. Children, here If you take mistakenly a greater number instead of a smaller number, then error should be subtracted. Now corrected mean x bar equal to sigma xi by n. So sigma xi is 387, number of observations is 9. Children, can we cancel these terms? Yes, 9 ones are 9 4s are 36, 9 3s are 27. So what I am getting here? 43. Now let us understand properties of arithmetic mean. Arithmetic mean is a representative value of the entire data. Children, you already understood that we cannot take individual value to represent the total data. Then what should be taken? Arithmetic mean can be taken. So I can say that arithmetic mean is a representative value of the entire data. Arithmetic mean depends on both number of observations and value of each observation. Arithmetic mean is a unique value of the data. Children, for a given data, we cannot find more than one mean. So we can say that arithmetic mean is a unique value. When all observations of the data are increased or decreased by a certain number, the mean also increases or decreases by the same number. When all the observations of the data are multiplied or divided by a certain number, the mean also multiplies or divides by the same number. Children, try to understand these two. If it is increased, mean also will be increased. If it is decreased, mean also will be decreased. So I can say that if all the observations are increased, mean will be also increased. If all the observations are decreased, mean will be also decreased. If all the observations are multiplied with a certain number, mean also should be multiplied with the same number. If all the observations are divided with a certain number, mean also should be divided with the same number. Arithmetic mean by deviation method. See children, arithmetic mean is equal to estimated mean plus average of deviations. So estimated mean is taken as A, average of deviations is taken as sigma xi minus A by n. Children, try to understand this. Deviation is nothing but the difference between estimated value and the observation. See children, this is the observation and this is the estimated value. The difference can be taken as deviation. So how to find average of deviations? It is very simple. Sum of all the deviations by number of observations. So we can say sigma xi minus A by n. Arithmetic mean equal to A plus sigma xi minus A by n. Children, this is the formula used to find arithmetic mean using which method? Deviation method. Now let us find the mean of 10 observations. See children, here I am taking 10 observations by assuming mean as 40. These are the 10 observations. From this, we are assuming mean as what? 40. So what I am doing here? Estimated mean or assumed mean is equal to A equal to 40. So arithmetic mean equal to A plus sigma xi minus A by n. So what I am doing here? A is nothing but 40. So what is xi minus A? Xi, first one is 14. 14 minus 40, you will get minus 26. 36 minus 40, minus 4. 25 minus 40, minus 15, and so on. Like this we have to find the deviations, and I am finding last deviation here 62 minus 40, which is equal to 22. Like this we have to find all the deviations and we have to find their sum and we have to divide with the number of observations. So what I am getting here children? Minus 70 plus 50 by 10. So I can say 40 plus minus 70 plus 50. So I will get minus 20 by 10. Can we cancel the terms here? Yes. So 10 ones are 10 twos are. So I will get minus 2, 40 minus 2, which is equal to 38. Find the sum of deviations of all the observations of the data from their mean. So what you have to do now? Yes, we have to find mean first. So what is the formula used to find mean? Mean x bar equal to sigma xi by n. So I can say that sum of observations by number of observations. So I am finding the sum of observations dividing with the number of observations. What I am getting children here? 60 by 5. If I cancel 5 ones are 5 ones are 5 twos are. So I will get 12. So first I am finding the mean. Now what I have to find? Yes, I have to find sum of deviations. So sum of deviations of all the observations from their mean. See children, this is the mean, these are the observations. So what I am doing here, first observation minus mean 5 minus 12 plus second observation minus mean 8 minus 12 plus and so on. So if you do like this, what I am getting here is minus 7, minus 4, minus 2, 15 minus 12 is 3, 22 minus 12 is 10. If I add minus 7 plus into minus minus 4 plus into minus minus 2 plus 3 plus 10. See children, here we have 3 negative values. So I have to add them. 7 plus 4, 11, 11 plus 2, 13. So I will get minus 13, 3 plus 10, 13 plus 13. If I cancel these terms, I will get 0. So what I am getting children here? Sum of deviations of all the observations of the data from their mean is 0. Now let us understand what is median. The middle term of the distribution when it is arranged in either ascending or descending order. If the number of observations n is odd, then n plus 1 by 2th observation is the median. See children, here when we get a odd number of observations, we will get only one middle term, that itself is called the median. If number of observations n is even, then average of n by 2th observation and n plus 1 by 2th observation is called median. See children, here when you have odd number of observations, we will get only one middle term, that itself is taken as median. But when you get even number of observations, we will get two middle terms. So the average of the two middle terms can be taken as median. Let us find the median of the data. Children, what are the given observations here? Yes, 3.3, 3.5, 3.1, 3.7, 3.2, 3.8. Whenever we want to find median, first thing is we have to arrange them in order. Either you can arrange them in ascending order or you can arrange them in descending order. So what I am doing here, arranging these observations in ascending order. First 3.1, next 3.2, next 3.3, 3.5, 3.7, 3.8. Now how many observations are there? Let us count. 1, 2, 3, 4, 5, 6. So we have 6 means even number of observations. So we will get two middle terms. What are the two middle terms here? Yes, 3.3 and 3.5. So median is equal to the average of these two. So median equal to the average of these two observations, that is 3.3 plus 3.5 by 2. So what we will get here? Yes, 6.8 by 2. After cancellation, what you will get? Yes, you will get 3.4. What is the median of the data? Yes, it is 3.4. Now let us understand properties of median. Median is the middlemost value in ordered data. Median depends on number of observations and middle observations of the ordered data. Children, try to understand here. First thing is it is middlemost value. Second, it depends on number of observations and it depends on middle observations. So median is not affected by any change in extreme values. Now let us understand what is mode. The most frequently occurring value in the group of given observations is called mode. Mode of the data may or may not exist. Children, if I ask a question like this, what is the mode of 1, 2, 3, 4, 5? Is any number repeated here? No. So we can say that mode is not defined. So mode may or may not exist. Data having one mode is called unimodal data. Data having two modes is called bimodal data. Now let us find mode of the data. Given observations in ascending order. Children, what I am doing here? I am finding the mode for this data. First, to find the mode, I am arranging them in ascending order. 9, 10, 10, 10, 11, 11, 12, 15, 19, 20, 21. Children, you observe the screen and tell me which number is repeated for more number of times. 10 is repeated for 3 times. 11 is repeated for 2 times. So I can say that 10 is occurring for 3 times and 11 is occurring for 2 times. Now which number is occurring for more number of times? Yes, it is 10. So what we can say, mode of the data is 10. So the above data is called unimodal data. Mode of the certain scores is x. If each score is decreased by 3, then find the mode of the new series. Children, what is given here? Mode of the series given as x, and you try to understand this one. If each score of the data is decreased by 3, then mode of the data also decreases by 3. Not only decreases, if it is increased, mode will be also increased. So, as it is decreased by 3, mode also must increase or decrease? Yes, it should decrease by 3. So, I can say mode of the new series is x minus 3. Properties of mode. Mode is the most frequent observation of the given data. Mode depends neither on number of observations nor on values of all observations. Mode is used to analyze both numerical and verbal data. For a given data, there may be 2 or 3 or many modes. Children, already I said that it can have mode or it cannot have mode. When data is having mode, it can be 2, it can be 3, or it can have many modes also depending on the given number of observations. Let us find mean, median and mode of the data. Children, observe the screen here. Given observations, I am arranging the observations in ascending order. 2, 2, 2, 4, 5, 5, 6, 7, 8, 9. I arranged these observations in ascending order. Children, what is the formula used to find mean? Yes, it is x bar equal to sigma xi by n. So, sum of the observations by number of observations. How many observations we are here? We are taking 10 observations and we have to find the sum of observations. So, when I add this, what I am getting here? Yes, I am getting 50 divided by 10. See children, when we add 2, 2, 2, 4, 5, 5, 6, 7, 8, 9, we get 50 divided by 10. Can we cancel the terms here? Yes, 10 ones are 10 5s are. So, what I am getting here? 5. So, what is the mean of the data? Yes, it is 5. Now, let us find median of the data. Observations in ascending order is there, and try to count the number of observations here. Yes, it is 10. As it is even number, we will have 2 middle terms. Children, what are the 2 middle terms here? Yes, 5. So, how to find the median? Average of these two. What is meant by average? Just to find the sum and divide with the number of observations. So, 5 plus 5 by 2, which is equal to 10 by 2, which is equal to 5. If I cancel, I will get 5. So, what is median of the data? Yes, it is 5. Now, children, how to find the mode? Yes, 2 is repeated 3 number of times and 5 is repeated 2 number of times. So, what I can say here? 2 is occurring for 3 times and 5 is occurring for 2 times. So, from this what we can understand? Mode of the data is 2. Why? Because 2 is repeated for more number of times. Grouped frequency distribution. Children, representation of given observations of the data into classes with frequencies is called grouped frequency distribution. Classes are nothing but the groups here. So, what I am doing? I am taking an example here. I am taking marks of 50 students in a FA. So, if I take a table here, I am taking the marks 1 to 5, 6 to 10, 11 to 15 and 16 to 20. See children, you know what is FA? Okay, teachers will be conducting for 20 marks, right? So, I am making 4 groups here. What are the 4 groups here? Yes, first group is 1 to 5, second group is 6 to 10, third group is 11 to 15, fourth group is 16 to 20. Now, how many children got 1 to 5 marks here? Yes, 6 students, and 6 to 10 marks 15 students, 11 to 15 marks 20 students, and 16 to 20 marks 9 students. And what is the total number of students here? Yes, 50. I am preparing a table or frequency distribution table with the help of classes and with frequencies. So, I am calling it as grouped frequency distribution. Now, let us understand what are inclusive classes. Classes like 1 to 5. See children, we have to read this as 5, 1 to 5, 6 to 10, 11 to 15, 16 to 20 are called inclusive classes. Why these classes are called inclusive classes? Let us understand. The class interval, I am taking the first one here, 1 to 5, has all the observations between 1 and 5. Children, try to understand here. If I take a class here 1 to 5, all observations between them should be taken. including both 1 and 5 means 1 should be taken and also 5 should be taken. As both these limits are included in the same class, we are calling the classes as inclusive classes. In the class interval 1 to 5, 1 is called lower limit and 5 is called upper limit. Children, I am taking a class here. What is the class here? 1 to 5. What is the starting number? Yes, 1. So, we are calling it as lower limit. And what is the ending number? Yes, it is 5. So, we are calling it as upper limit. In case of inclusive class intervals, limits and boundaries are different. Let us understand what are exclusive classes. Classes like 0 to 5, 5 to 10, 10 to 15, 15 to 20 are called exclusive classes. Children, let us understand why these classes are called exclusive classes here. The class interval, I am taking the first one here, 0 to 5, has the observations between 0 and 5, including 0 and excluding 5. Why we have to exclude 5? Let us understand. If I take 0 to 5 class, if I include 5, then you will get a doubt here. 5 should be taken in first class or second class? Yes, there is a problem. So, what we do here, we will take 5 in the second class. So, from this what we can understand, if I take 0 to 5 class, I can take each and every value from 0 to 5, but not 5, means less than 5 should be taken. In the same way, here if I take the second class, 5 to 10, from 5 to 10 we can take, but we should not take 10, means we can take values less than 10. Children, one question here, if you have inclusive classes, what is the need for taking exclusive classes? Yes, suppose in a FA, if a student is getting 5.5 marks, suppose 5.5 marks, where he is to be taken, there is a problem. So, we need exclusive classes. So, when we have integer values, we can go for inclusive classes, and when we have decimal values, we can go for exclusive classes. The class interval 0 to 5 has the observations between 0 and 5, including 0 and excluding 5. In the class interval 0 to 5, 0 is called lower limit and also called lower boundary. 5 is called upper limit and also called upper boundary. In case of exclusive class intervals, children we can call them as continuous series. Limits and boundaries are the same. So, from this what we can understand, for inclusive classes, limits and boundaries are different. For exclusive classes, limits and boundaries are the same. Let us understand lower and upper boundaries. See children, I am taking the classes here 0 to 5, 5 to 10 and so on, we are calling them as exclusive classes. If I take the class here 5 to 10, the lower boundary will be 5, the upper boundary will be 10, because these classes are exclusive classes, limits will become the boundaries. See children, here I am taking inclusive classes. For this, limits are different, boundaries are different. How? Let us understand. If I take 6 to 10 class, okay, how to find the lower boundary? This is the 6, I am taking this 6. You have to take the upper boundary of the previous class, that is 5. So, I have to add them and divide with 2. So, 5 plus 6 by 2, I will get 5.5. In the same way, 10 plus 11 by 2 will get 10.5. So, from this what you can understand here, the lower boundary of 6 to 10 class is 5.5, upper boundary of 6 to 10 class is 10.5. Lower boundary and upper boundary of a class are called its true class limits. Length of the class. The difference between upper and lower boundaries of a class is called length of the class. So, I can say C is equal to UB minus LB. If the classes are 0 to 5, 5 to 10 and so on, for the class if I am taking 5 to 10, see children, these are exclusive classes. So, I can say limits are the boundaries. So, I can say 10 minus 5 equal to 5. Okay. So, for the class 5 to 10, lower boundary is 5, upper boundary is 10. So, I can say C is equal to UB minus LB, that is 10 minus 5 equal to 5. If the classes are 1 to 5, 6 to 10 and so on, these are inclusive classes. Okay, I am taking in that for the class 6 to 10, lower boundary will be 5.5, upper boundary will be 10.5. So, class length or length of the class can be taken as UB minus LB, which is equal to 10.5 minus 5.5, which is equal to 5. Okay, children, try yourself. Find the mean of 20, 11, 21, 25, 23 and 14. Find the median of 14, 25, 28, 32, 35, 36, 42, 50, 56. Find the mode of 1, 4, 2, 5, 2, 3, 2, 3, 5, 3, 6, 4, 6. Arithmetic mean of 9 observations was calculated as 45. In doing so, an observation was wrongly taken as 42 instead of 24. Find the correct mean. Okay children, In this session, you learnt about the measures of central tendency, that is mean, median and mode, and at the same time you learnt about what are class limits and what are class boundaries. In your next session, you are going to learn frequency distribution, tables and graphs. For better understanding of the concepts, solve the worksheet. Please visit the official website of SCRT for worksheet. Okay children, let us meet in our next session. Thank you.